This is problem number 4 on the sample test problems for test number 2. Without using a calculator, state whether each of the following is positive or negative. Cosine of -1, sine of -1, cosine of 2, sine of 2. So since this is a non-calculator question, we might be thinking unit circle. Unfortunately, these angles that we're talking about in this problem are not on our unit circle. Notice there's nothing here with pi's. Cosine of 2, that's 2 radians. 2 radians is not a particularly nice angle, and it doesn't appear on our unit circle anywhere. So we're not going to find it on the unit circle. So we need to have a different approach here. So what I think we want to do is maybe start by drawing just a rough sketch of the unit circle, but then we'll focus on the angles that we're interested in, even if they're not nice in terms of having points on the unit circle. So here's my unit circle, and what we're interested in is labeling the quadrants. So this top angle, the straight up point up here, is pi over 2, and out here is pi. Down at the bottom is 3 pi over 2, and then back at the beginning, 0 or 2 pi. And in this case, because my angles in this problem don't have pi's in them, I'm looking at an angle of -1 radian and 2 radians. What I'd like to do is maybe translate these pi things to approximations. So pi is around 3 and some change. So that makes pi over 2 about 1.5. And 3 pi over 2 is then about 4.5. And then 2 pi is around 6. Not perfect, but it's going to be good enough. And so if I'm interested in finding where, for example, cosine of 2 is, let's see, so I want 2 radians. So if I'm figuring 2 radians, if I go up to the top, well, that's 1.5 radians. If I keep going to the far left, that's 3 radians. I wanted 2 radians. So 2 radians must be in here somewhere. So let's just call it somewhere around there and estimate this angle right here as 2 radians. And the only other piece to this problem is knowing where the different trig functions are positive. So however you remember A, S, T, and C in that configuration, looking at this 2 radian angle, which is in the second quadrant, we know that the only trig function that's positive in the second quadrant is sine, and therefore also cosecant if you wanted it. So sine is the only one that's positive there. So that means that sine of 2 is positive. That one's bigger than 0. And cosine, well, it isn't sine, and sine is the only one that's positive. So cosine must be negative. And now we'll play the same game with the angle of -1. Okay, so if I were to pretend for a moment that that angle was really +1, where would it live? Well, again, if I get to the top, then I have gone 1.5. And if I'm only interested in going 1 radian, then I shouldn't quite get to the top. So 1 radian is less than, a quarter of a revolution. So -1 radian must be somewhere less than a quarter of a revolution going clockwise. And so 1 radian then is somewhere down in here. -1 radian is down there. And so we play the same game as before. We're in the fourth quadrant. The only trig function that's positive is cosine. So the cosine of -1 must be a positive number. And sine, because it isn't cosine, must be a negative number. If you prefer thinking about everything in terms of degrees, then you might want to do a little translating. You don't have a calculator, so you'll have to know something, some fact about going between radians and degrees. So you might remember that 1 radian is approximately 57 degrees. So when we said -1 radian was down here, okay, that jives because 57 degrees is right around where we drew this angle down here in the fourth quadrant. And then 2 radians is therefore something around 114 degrees. And so did we do well on that one? Yeah, 114 degrees is somewhere in the second quadrant.